Hi students, today I am going to explain some more properties of gamma function and the results which we need to solve problems on that gamma function. Okay, first step I want to prove that gamma, this is one property, that is gamma of n is equal to integral 0 to 1 log of 1 by y whole to the power of n minus 1 into y. Okay, this is one property. I want to prove this property. What I know about gamma function is just the basic definition. I know this only. That is gamma of n is equal to integral 0 to infinity e power minus x to the power of n minus 1 into dx. Is it okay? We know this. If I compare this result with this one, my intuition says that put log of 1 by y in place of x, since the power of log of 1 by y is n minus 1 here and the power of x is n minus 1 here. Therefore, I write substitute x is equal to log of 1 by y. Okay. While solving definite integral, if I replace variable by some other substitution, I need to find the derivative of that and I want to change the limits also. So, if x is equal to log of 1 by y, your dx is equal to differentiation of this log. Differentiation of log function is 1 over the denominator, that is 1 over 1 by y. Since 1 by y is still a function of y, I differentiate that minus 1 by y square into dy. Okay. Here this is because dy by dx is equal to dy by dt into dt by dx if y is function of t. This is the basic definition. There is no necessity of recalling this thing, I think. Okay. So I write like this. That is dx is equal to, if I simplify the things, this y goes to the numerator, y goes with this y, and this is equal to minus 1 by y into dy. Okay. When x is equal to 0 implies that log of 1 by y is equal to 0, which implies that y is equal to, what is that? What is that? Y is equal to, I am substituting x is equal to 0. Is it not? Log of 1 by y is 1 by y is equal to e power x. Okay. 1 by y is equal to e power x, that is it is e power 0, which implies y is equal to 1 by e power 0, 1 by e power 0 is 1. When x is equal to infinity, then log of 1 by y is equal to infinity. This implies 1 by y is equal to infinity, e power infinity. This implies y is equal to this is the condition, the limit of e power y as y tends to infinity. Okay. Actually, there is no necessity of writing all these things, I think. If I write when x is equal to 0, this condition holds. Okay. Then gamma of n is equal to when x is equal to 0, the value of y is 1, and when x is equal to infinity, the value of y is 0, and it is e power minus log of 1 by y, log of 1 by y into x to the power of n minus 1. X means what is that? This is log of 1 by 1 whole to the power of n minus 1 into dx means I have to write this as minus 1 by y into dy. I don't want minus sign here. ನಾನು ಯಾವಾಗ ಹೇಳ್ತೀನಿ ನಾನು minus sign ಅಂದರೆ ಇಷ್ಟ ಇಲ್ಲ. So in order to remove this minus sign, I replace this lower limit to upper limit and upper limit to lower limit, so that this negative side will cancel. Here if you observe this, e to the power of minus log of 1 by y means you have to write this as e to the power of log of 1 by y whole power minus 1, since n log x is equal to log x power n. I am using that property here. That is log of 1 by y whole to the power of n minus 1 into 1 by y into dy, since log x power n is equal to, I am recalling that this is n log x. Is it okay? Now I write gamma of n is equal to integral 0 to 1. You know that e power log x is equal to x itself. Therefore, this is equal to 1 by y whole power minus 1 into log of 1 by y whole power n minus 1 into 1 by y into dy. So, your gamma of n is equal to integral 0 to 1 log of 1 by y whole power n minus 1 into dy. You observe this. This is 1 by y whole power minus 1 and this is 1 by y whole power 1. If you consider the product, it is 1 by y whole power minus 1 plus 1. Is it okay? This is the result we require. Okay. Next property I want to prove is second property. What is that? Gamma of n into gamma of 1 minus n is equal to pi over sin n pi. You want to prove this result. If you observe this result, here there is product of two functions. One is gamma of n and another one is gamma of 1 minus n. I know only this result. Is it okay? This is proof for this is, if I ask you to prove this, beta of n comma n is equal to gamma of m into gamma of n over gamma of m plus n if m comma n greater than 0. Okay? This is like this. If I observe this result, and beta of m comma n is equal to, in last class I proved this result. What is that? Integral 0 to infinity x to the power of n minus n over 1 plus x whole to the power of n plus n into dx. Okay? Therefore, if you call this result as result number 1 and this as result number 2, from result 1 and 2, I can able to write this as gamma of m into gamma of n, gamma of n divided by gamma of m plus n is equal to integral 0 to infinity x to the power of n minus 1 over 1 plus x whole to the power of m plus n. I came across this equation number 3. Now you observe, I want to prove this result. Actually here gamma of n into gamma of 1 minus n is present. This is okay. If I replace m by 1 minus n. If I replace m by 1 minus n, I am going to get gamma of 1 minus n into gamma of n divided by gamma of 1 minus n plus n, which is equal to integral 0 to infinity of x to the power of n minus 1 over 1 plus x whole to the power of m plus n. M plus n means it is 1 minus n plus n into dx. Okay, that is gamma of 1 minus n into gamma of n. Gamma of 1 minus n plus n means it is gamma of 1. Gamma of 1 is nothing but 1. In my first video, I defined that it is equal to integral 0 to infinity x to the power of n minus 1 over 1 plus x to dx. That is the power of 1 minus n plus n is 1 only. Therefore, gamma of 1 minus n into gamma of n is equal to integral 0 to infinity x to the power of n minus 1 over 1 plus x into dx, since gamma of 1 is equal to 1. Now I look at this result. To this result, if this integral is going to be this pi over sin n y, then this value becomes that much. Therefore, gamma of n over gamma of 1 minus n is equal to pi over sin n pi if integral 0 to infinity x to the power of n minus 1 over 1 plus x into dx. Hence the result. Okay. Next property is prove that gamma of n plus 1 is equal to integral 0 to infinity e to the power of minus 5 whole to the power of n into. For all these things, I am using the basic definition only, not more than that. I know that what is that gamma of n is equal to integral 0 to infinity e to the power of minus x to the power of n minus 1 into dx. This is okay. Now, if I compare this RHS with this part, what you observe is in place of the power of x, in place of the power of e, Here minus sign is common in both the cases. Here in place of x there is y to the power of 1 by n. Therefore, I use the substitute. What is that? X is equal to substitute. X is equal to y to the power of 1 by n. As I told you earlier, if I replace variable by some other variable in the sense if it is not the linear variable or the same variables, one variable with the other variable, there will not be any change. But if I change like this, its derivative also going to change. Therefore, I write the dx as, I want differentiation this y to the power of 1 by n. Therefore, this is 1 by n into y to the power of 1 by n minus 1, which is equal to into dy. That is dx is equal to 1 by n into y to the power of 1 minus n divided by n into dy. Okay? Or else you can write like that. There is no necessity of writing this step also, I think. Okay? Now, when x is equal to 0, y is equal to x. You observe this. When I am substituting x is equal to y to the power of 1 by n, this indicates that y is equal to x to the power of n. Therefore, if I substitute x is equal to 0, y is equal to 0 to the power of n, therefore 0. And when x is equal to infinity, y is equal to infinity. Therefore, gamma of n is equal to integral 0 to infinity e power minus x, that is e power minus y whole to the power of 1 by n into x power n minus 1. And I am substituting all these things in this equation only. If you want to write this equation as equation number 1, this as equation number 2, and this as equation number 3, and this as equation number 4, I have to write substitute 4, 3, 2 in equation number 1. If you want, you write like this. Otherwise, we can follow, if you think that we can follow these things, there is no necessity of numbering all those things. It is e to the power of minus y whole to the power of 1 by n into x power n minus 1. X power n minus 1. What is that? X value is y to the power of 1 by n whole to the power of n minus 1 into dx means it is 1 by n into y to the power of 1 by n minus 1 into dy. Now, if you simplify this, here n is a number, therefore you can take that outside the integral sign, and I don't want that n here means you can cross multiply that. Or else, if you are unable to understand this, you have to write one more step. That's all. If you feel any difficulty in following the steps, you have to write one more step. It is e to the power of minus y whole to the power of 1 by n into y to the power of 1 by n into n means it is 1 minus 1 into 1 by n means it is 1 minus 1 by n, and here the power is 1 by n minus 1. To observe this, here plus 1 and it is minus 1, it is minus 1 by n and it is plus 1 by n. Therefore, the power is going to be 0, that is y power 0. Y power 0 means it is nothing but 1. Is it okay? Now I write this as gamma of n is equal to 1 by n. I don't want to I cross multiply that. N gamma of n is equal to integral 0 to infinity e power minus y to the power of 1 by n into 1 into dy. Into 1 means it is nothing but the same value. I write like this. What is that n gamma n? Already in the last classes we proved that gamma of n plus 1 is equal to n gamma n. Therefore, I write this as gamma of n plus 1 is equal to integral 0 to infinity e to the power of minus y whole to the power of n into dy. Hence the result. So, okay. Now, I want to prove one more result. Prove that gamma of 1 by 2 is equal to 2 times integral 0 to infinity e to the power of minus y square into dy, which is equal to root y. I want to prove this result. Is it okay? Now, what I am doing is, I consider the previous result. Right? We know that gamma of 1 by 2 is equal to integral 0 to infinity e to the power of minus gamma of n plus 1 is equal to e to the power of minus y whole to the power of 1 by n into that gamma of n plus 1 is equal to, here gamma of 1 by 2 is there. Therefore, I write gamma of n plus 1 as n gamma of n is equal to integral 0 to infinity e to the power of minus y whole to the power of n into dy. Is it okay? Now, I write put n is equal to 1 by 2 in the above equation. In this result, I put n is equal to 1 by 2. It is 1 by 2 into gamma of 1 by 2 is equal to integral 0 to infinity e to the power of minus y whole to the power of 1 over 1 by 2. You observe this, just I am substituting the value of this number n as 1 by 2. So, there is no necessity of changing anything here. Just I am substituting 1 by 2 in place of n only. Now, I simplify that. It is 1 by 2 into gamma of 1 by 2 is equal to integral 0 to infinity e to the power of minus y. 1 over 1 by 2 will become 2 into dy. If I cross multiply this 2 with this, I came across gamma of 1 by 2 is equal to 2 times integral 0 to infinity e power minus y square into dy. Still, my part of work is left here. Just I put that gamma of 1 by 2 is equal to this much, but yet I have to prove that it is equal to root y. Therefore, similarly, you can write this as gamma of 1 by 2 is equal to 2 times integral 0 to infinity e to the power of minus 6 square into dx. Since we know that if we change the single variable by the single variable, value of the definite integral will not alter. You do one thing, you call this equation as equation number star and this as double star. Okay. If you multiply equation multiply equation star and double star, we get what is that? We multiply left hand by left hand and right hand by right hand. Is it okay? Now this is equal to gamma of 1 by 2 into gamma of 1 by 2. Therefore, I write this as gamma of 1 by 2 whole square, which is equal to 2 into 2 is going to be 4. It is integral 0 to infinity e power minus y square into dy, integral 0 to infinity e power minus x square into dx, which is equal to 4 times integral 0 to infinity, integral 0 to infinity. Since the base is same, I add the power, that is e power minus of x square plus y square into dx into dy. Yes, I'm writing. Okay. Even if you don't want to alter like this, you can do one thing. You can write this as the equation star and double star means it's okay. It is e power minus x square into dx and it is e power minus y square into dy. It will be same. Here dx into dy. Now, it is hard to integrate this result. So, double integral ಮಾಡಬೇಕಂದ್ರೆ ನಾವು ಏನು ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಕಾರ್ಟೀಸಿಯನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡೋದು ಕಷ್ಟ ಆದಾಗ ನಾವೇನಂತ ಹೇಳ್ಕೊಟ್ಟಿರ್ತೀವಿ ಅಂತಂದ್ರೆ you change it into polar coordinates to make it simple ಅಂತ ಹೇಳ್ತೀವಿ. ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ? You understand? If you want to integrate it in a simple way, you change the Cartesian coordinates to polar coordinates. You observe this, that is x is equal to 0 to infinity means on the x-axis it is like this 0 to infinity. On the y-axis it is also 0 to infinity. So here the entire thing in the first quadrant comes for this double integral. Therefore, if I want to change this into Cartesian coordinates, I consider r, that is the value of r. You observe this, the value of r changes from 0 to infinity. Since it covers the entire space, r ranges from 0 to infinity and theta ranges from 0 to pi by 2. Therefore, changing into polar coordinates, changing into polar coordinates, gamma of 1 by 2 whole square is equal to 4 times integral 0 to infinity, integral 0 to pi by 2 e power minus, changing into polar coordinates, you must remember the concept that changing into polar coordinate means we have to remember the concept that put x is equal to r cos theta, y is equal to r sin theta, and the value of that dx into dy by r into dr into dt. Okay, that is the surface integral. Now I can able to write this as gamma of 1 by 2 whole square is equal to 4 times integral 0 to infinity, 4 times integral 0 to infinity, and this is 0 to pi pi by 2 e power minus of. If I am substituting x is equal to r cos theta, your x square is going to be r square cos square theta, and y is equal to r sin theta plus y square is equal to r square sin square theta. Therefore, x square plus y square is equal to r square into sin square theta plus cos square theta. Okay, into dx into dy, that is r into dr into d theta. Okay, now this is equal to 2 times integral 0 to infinity 0 to pi by 2 of here first 0 to pi by 2 means here theta is present. Therefore, first I integrate with respect to theta. Next, I integrate with respect to r, that is e power minus r square. Since I am writing this 4 as 2 into 2, therefore this is 2r into dr. Okay, now write this as 2 times integral 0 to infinity. If I integrate 1 with respect, nothing is here means 1 is here. Therefore, if I integrate 1 with respect to theta, I am going to get theta, and the value is between 0 to pi by 2, and this is e power minus r square into okay, now I write this as 2 times integral 0 to infinity. If I am substituting the upper limit, it is pi by 2, and if I am substituting the lower limit, it is 0 into e power minus r square into 2r into dr. Is it okay? Now, if I take this pi by 2 minus 0 as pi by 2 outside, it is 2 times pi by 2 integral 0 to infinity e power minus r square 2r into dr. 2 get cancelled, and this is equal to pi. You observe this integration is just like this. It is e to the power of minus f of x into f dash of x into dx, like this integration. We know that this formula for this is equal to integration is this. It is e to the power of minus f of x over minus 1. Therefore, I write this as e power minus r square divided by minus 1 in between the limit 0 to infinity. If I substitute the value, that is the limit as r tends to infinity, this is going to be e power minus infinity. This is going to be 0. Minus into minus will become plus. When I am substituting r is equal to 0, this is going to be e power minus 0. It is nothing but 1 by e power 0. It is 1. Thus, gamma of 1 by 2 whole square is equal to pi over. Therefore, gamma of 1 by 2 is equal to 2 pi. Hence, gamma of 1 by 2 is equal to 2 times integral 0 to infinity e power minus y square into dy, which is equal to 2 pi. Hence the result. Okay friends, I will discuss about the other properties and problems in the next class.